Thank you for joining the next session of embedded software testing. This is Unit 4 concluding session on software integration, regression testing, automation, and we study more about uh, selecting regression tests, test maintenance, regression test build process. What are the steps that are involved for regression testing build process, test strategy, and we'll try to recap the session of the unit 4, all the sessions. So before that, we just do a quick walkthrough of what we have understood in our earlier session. We understood about the integration test environment, like it could be host-based processor or emulator, or it's a actual target. So we have a different sort of integration, like software unit level, software integration level, software to hardware level, and hardware to software level. So likewise, we have integration test environment defined, and also there is another aspect of integration test is a system integration test, which involves system level, where we use the real target as well as the rest of the embedded systems surrounding that also will be a real one. I mean, in terms of pre-production one, where we use actual models or prototype models of the other embedded systems which are required. For example, if any input is need to be triggered, we are going to trigger with a actual function generator or whatever it is. We will not use the stubs or any drivers for driving the values. So that is where the system integration test will take care. And next to that is the actual system test, which is on the production board, and also it is a acceptance test where we deliver the finalized product to the customer with a sampled acceptance as per the specification that is required. So that is a typical V&V aspects what we or in the industry they follow basically. Also, we studied about integration from use case perspective, like we have a user perspective understanding the embedded system, and a lot of scenarios will be drawn. Each scenario can have multiple or a single test cases. For each test cases, as usual, we will have a test case procedures, scripts, and execution philosophy. And basically, the observed behaviors of the system will be perceived from the user's perspective. That is where the use cases are going to be used. So if you have a models or architecture written such a way that it can be tested from the use case perspective, it's good to have integration done from the use case perspective. So what we do is we first describe the users or the actors and describe the scenario, and for each of the scenario we'll write the test cases. So it's called as goal driven use cases. And generating the test cases from use cases, basically there are a lot of tools are available. First, we develop the use cases with the help of tools such as UML, Unified Modeling Language. Basically, it is a modeling language where we predict and model the embedded systems in terms of various diagrams. But for developing the test cases, we represent use case diagrams. We will try to understand few examples of use case diagrams today, though it is not part of the scope, but I'll just try to explain one or two slides. And typically the use cases will have name of the user or the tester or the actor, it is called as, and a description of what the use case is going to do, or what the user is going to interact, how it's going to interact. Next one is the flow of events. What are the flow of events that user can do, and any requirements that is getting addressed, any special requirements that is getting addressed, and preconditions for doing that flow. Similarly, post conditions after that scenario is being completed. So likewise, we are going to have use cases, and accordingly we are going to generate the test cases. You can see an example here, figure what we have seen. It's a basic flow of events and alternate flows. You can see in red marked ones the use case. Here there is a difference. This is grounded in the sense it is going to end there. End of use case. They mark this way. Typically, the flow, basic flow surround that the alternate flows will be drawn. Like alternate flows 1, 2, 3, 4 depends on the type of system that we use. For each of these flows, we are going to have test cases, 1 or 2 test cases. You can see example 1 to 5 test cases are written. The test cases can also have multiple flows involved because we need to achieve to reach the path. That is why we need to generate. So basic steps for generating the test cases involve. For each use case, generate a full set of use case scenarios. For each scenario, identify at least one test case and the conditions that will make it execute. And for the test case, identify the data values, that is the objects or the inputs that are going to be used with which we are going to test it. The data values can also be a condition uh, with which we are going to vary and trigger, and the data values also will have a expected output as well as the actual output that is going to be provided when we are going to, that is going to be output when we execute the test case. Then after the use case example, we had studied about regression testing. Regression testing can be divided as retesting and regression testing. Retesting is testing again and again. Regression testing is retesting on a previously developed program with the fixes to make sure that the faults that were there before are cleared this time. So that is where regression testing is important. So basically, we use the same test suite. The requirements will be same. Only thing is the code which had earlier bugs have been fixed, and we have a new version of the build on which we are going to re-execute. That is where regression testing is used. Also, it is called as one of the strategy for maintenance testing. We'll try to understand what is maintenance testing in today's session. So the changes that are there in the systems are to be tested with the help of regression test suite. But the chances are that along with the fixed test suite, there could be an impact on the other tests also, which could be failing now, which were passing earlier. So we need to be choosing the regression testing scenario such a way that the analysis and the impact of the fixes that are updated on the existing build needs to be redone. So the changes can be of three types. It is on the impacted component itself, specific changes or specific line or a small system, small subsystem, etc. Or a complete test, retest of the function. We may have to do it to make sure that regression is taken care. Also, the third type is the coherence or the interaction of the changed components with the adjacent components of the surrounding models where the impact is there. So all these three areas we need to take care. Regression testing test strategy definitely depending on the number of changes and the kind of changes. So we need to evaluate what are the risks that are going to be evaluated and how we are going to plan and progress the tracking of the embedded systems for regression testing. And sometimes we may have to treat it as a new way of doing the test. as if the code is being newly developed. So test strategy is to change, identify the or determine the changes, determine the relative importance of the changes and regression, selecting quality characteristics, determining the relative importance of the quality characteristics, determining the relative importance for each change of the quality characteristics combination, and establishing the test techniques which have to be used for regression testing. Regression testing areas are regression due to fixing the fault. Regression can be for added functionality. Regression can be on the same build, same requirement, same specification, but it's on a ported platform or a new platform. Regression can be due to new configuration or after the customization of the software. Software has not changed, but it is configured for a different values with a different customized situation. Regression and delivery planning, that also need to be planned. Regression testing automation is also one of the important areas where we are going to develop regression test suites under configuration control. So automation can be developed over a period so that every time we don't have to re-execute certain bundle of tests manually. So we can automate those batches as a automated script execution so that regression can go smooth, and it is going to be an incremental development. And there is a regression test matrix, the relative importance of changes and the regression. The changes could be due to change requests that are occurred during the fixes or new features, whatever it is. The changes could be due to defects that were identified during the testing, and the importance could be 30 to 40%, 10 to 30% based on the type of uh, system that we have. So that is how the relative importance of regression they will be working out. The basic problems of regression test is maintenance test suite and cost of retesting. If the feature X is changed, how many test cases we have to execute for that feature or impacted X, because the revised X could impact on the other areas as well. And what test cases I need to remove, what should be added, all these have to be taken care. So we may have a test suite or the test bench with the batch files, but in that batch files all may not be needed because we are wasting unwanted things. We need to choose. So that is a maintenance, so it is going to cost some effort. And cost of retesting often proportional to product size, not change size. So basically, what sort of a change we have and what is the total size of the product. So that drives the cost of the retesting. So basically, it requires a manual effort for doing the regression at times. Why? Because the changes are too much and we cannot afford to have the same sort of a automation. Sometimes the changes are very minimal, so entire bunch we don't need to re-execute. We may have to choose or tailor the existing automation aspects. So that is what we have studied about the regression testing and the areas and the types of them. Today's session we will try to understand in continuation of the previous one, use case diagram example. I'll just brief it. So this is a typical use case diagram. You can see this diagram is drawn for an elevator system. You see use case have a actor and this elevator is a functional block. So there are different scenarios. You can see they are all in oval shape. Process car calls, move stop the car, open close the door, indicate moving direction, process all calls, indicate car position, trigger emergency brake. So all these are different scenarios that are used, and this can call for different test cases. So that is how we are going to have use case with the scenarios, actors, and the function blocks. And each of the scenarios need to be explained appropriately so that test cases can be drawn easily. So you can see another example. I'm not sure if it is clear. There is a operator or a user. So this is basically a operation of audio player. You can see user can do a listening audio or the recording audio. This basic functions he is going to act, and this listen audio can further have different operations or use cases scenarios, something like power on, play, pause, adjust volume, stop. Similarly, the record audio can also have the stop, etc. So these scenarios, for each of the scenarios, after seeing this, it's easy to draw test cases, right? So it's important to have such models having the use cases drawn so that the entire architecture for this operation block, for example, can be tested with the help of test cases. So it's easy to test, right? So probably we'll try to develop a test case as an assignment for this particular use case in the one of the session in the future lab exercise. So that is how use case diagrams are very useful and will be used for integration testing. Okay. So basically, the main contents of the use case diagrams are use cases itself, that is the complete thing with the scenarios. Then the actors, you can see it can have multiple actors also, because multiple users or users means doesn't mean that actual end user. It can be any function block which is calling sub function, or if there is an input or the triggering condition which can call for these flows. So that is how the actors are defined. And the third one being the dependency, generalization, and association relationship, how it is going to be associated with the diagram. So these three aspects or the contents will be there in the use case diagram. With the help of this, the test cases will be drawn. Okay, so coming to the regression testing, regression test cases, selecting and prioritizing the regression test cases is also one of the important point in the regression testing. So the question is, should we rerun the whole regression test suite? If so, in what order? The order is also very important, because we have different test cases flown in different manner. So, and the ease of use, the time, the effort, and conclusion, and the problem areas, all this matter in terms of realizing the tests. We cannot afford to have a high complex testing to start with. Why? Because we will be spending that in the beginning only, too much of a time, and later stages it's very difficult to pick up the small ones. So we need to have a balance of both the complexity as well as the simpler ones in order to make it a good order of regression tests. So for this question, answer could be something like, maybe you don't care. If you can rerun everything automatically over lunch break, do it. That means you have a confidence that that entire bunch can be rerun without any issues, without any stoppage for peak time, something like 2 to 3 hours. Then better to go for it for the entire regression suite or the bundle. But sometimes it is not true. We may have to take care, like we have to break up the existing test suite into such a test suite that it is going to map and realize the regression areas where we had issues earlier, and that is got resolved in the current execution. And accordingly, we need to prioritize the different types of regression test suites and test scenarios. So prioritization matters when a very large test suite cannot be executed every day. So we cannot have everyday operation in terms of test suite execution as a batch in regression testing. So we need to prioritize. So what is the priority? Functionality A, B, C, D. Suppose they are there, and we have for each function 4 test suites for A, B, C, D. Then we need to prioritize depending on the type of regression. That means A can have a high complexity, and that functionality is very key and important, and we need to prioritize that as a higher one. Whereas other functionalities like smaller functions or routine functions, which doesn't require much attention, can be having a low regression testing priority. Selection matters when test cases are expensive to execute. That means if it is going to occupy special equipment or licenses or any special tools, or it's going to cost more time, then selection is also very important. It's not just enough to have prioritization only. Prioritization and selection both matters for regression test cases, because again there is a cost involved, effort involved, all these sort of issues, complexity and dependency, all these matters in terms of regression testing execution. Test cases are expensive to execute because they require special equipment or long run times or cannot be fully automated. So this has been referred in the one of the Mauro Pezze and Michael Young's book. So nicely he has told that selection and prioritization of regression test cases are important. Okay, so another aspect of integration testing or the maintenance or regression testing is called test case maintenance. Sorry, there is a spelling mistake. Okay, test case maintenance is another aspect which has to be maintained for a period. Suppose the product is for 2 years and 50% of time is dedicated for testing. Definitely, we need to have an allocation and a dedication of this aspect called test case maintenance, where the test cases need to be maintained, because there is a chance that these test cases have to be revisited upon updation of the software, changes in the requirement, or customer confidence, or multiple platforms, etc. So all this can be taken care with the help of test case maintenance activity. So some maintenance is inevitable. If feature X has changed, test cases for feature X will require updating. So it is not just enough to have a regression test analyzed and used. It is also important to have an understanding of what got modified or added or changed, and accordingly we need to modify or alter the test case. We don't need to have a test case started from the scratch, because already we have the framework, the preconditions and all that elements available. We just accordingly we are going to maintain it in terms of updating it. Some maintenance should be avoided. Example, trivial changes to user interface or file format should not invalidate large. For example, there is a document, there is a small letter like I did some change here, test case maintenance. Of course, it's a big change, but in general, I'd say if the name of the signal is mentioned wrongly, but test case is working, so there is no point in doing such maintenance. So you can just document and record it somewhere or make a note, and when we actually look into that any other impacted changes, we can take up this as well, so that this can be prioritized and updated when we are going to do it. So some sort of a maintenance we can avoid. For the heck of doing maintenance, we should not be doing it. That is the meaning of that. Test suite should be modular. That means any dependency we should try to avoid as much, so that that can be independently executed. Generating the concrete test cases from test case specifications can help. That means or the concrete test cases we need to have. It is also called as a golden test case. It's an important word they use in embedded software testing. If you have this is the minimal test case which is used as a golden test, so that this works always. So if there is something stuck, something got issues, and we don't know where to go to do it. So what we do is we'll pick up this golden test rule or test case. We'll try to pass it on and execute, so that this is fine. There is some other issue specific to whatever we are trying to address in the other test case. So this will isolate the problems that we have. So the concrete test cases are very important in maintaining the test suite or test cases. That is where a test case maintenance is important. The next one is the regression testing build process. How are we going to have the build process done for the regression testing? You know what is build? Build is basically compilation, linking, and uh, development of the software. Similarly, we have the build process for the test equipment also, or the test scenarios or test scripts also. Again, they are going to have a compilation and logically grouping them and keeping it in a proper place, and making sure that license environment is fine. All these are part of the build process, and the bullet points for the same is baseline inputs in terms of complete build and executable lines of code, EOC, that is called as. That base should be available, because without which you cannot do a regression test, right? So baseline inputs is one of the important input. No change in requirements. Updated software, that means the build has changed. We have no change in test plan and test execution strategy. It is still same, but we are going to do a regression on the updated inputs such as EOC, executable lines of code, or the build, the binary. Then the last part will be delta review and updates of the incremental updates. So we need to review what got changed, what is updated, and we are going to do a regression test accordingly. So these are some of the build process we are going to have for the regression testing. So we start with the baseline input, and we are going to analyze the changes, and we are going to re-execute the software with this baseline input. The baseline inputs will be provided through a configuration control. Basically, configuration control will be done through various tools such as PVCS dimensions, SVM, JIT. A lot of tools are there. We will study that in the next unit, test management or configuration management. So, one example, you can see a diagram here that is been put for regression testing build process. You can see a repository of old binary and new binary will be added to the analysis, binary change analysis. This is basically a process block where basically analysis of what was there before old binary, and what is the change that is done on the new binary. Binary here means the executable code or the object that is going to be tested against, and we are going to do a coverage analysis of the changes that are there, so that what are the impacted areas that is being covered, and how are you going to test it. And for coverage analysis, definitely use the old coverage, old binary coverage, or the old whatever we have executed earlier with our earlier test suite. So that will be an important input. Then we are going to prioritize the test suites or the regression tests which we are going to start, and prioritized list of test cases we are going to come up with, list of impacted blocks not covered by existing tests. That means what are the impacted blocks which are not covered with the existing tests, that also will come out as an output of the test prioritization activity. So this will be a typical test building process of the regression testing. Okay. So having understood all this regression testing, test case maintenance, selection and prioritization of the regression testing, one question is that if only its environment is changed, we know that the environment could have been changed for the new thing. Is maintenance test is necessary? Answer is yes. Why? Because migration from one platform to another one testing should repeat the operational test with the new environment. We don't need to uh, re-execute everything, or we don't need to maintain the testing or the regression testing. Uh, Only thing that we need to take care is the operational tests, which are very much coupled with the target platform or the platform changes with the new environment, that needs to be considered and taken care. So that is where regression testing test strategies should adhere to. Okay, so with that we end the session of this lecture, and we'll try to recap this unit of regression and integration testing. So what are the topics we studied? So we studied about integration testing, definition and types of integration testing we understood. We also went through system integration, hardware software integration, software integration, etc. Integration basic steps. What are the integration steps that are involved? Types of integration: big bang, bottom up, top down, its advantages and disadvantages we studied, and we also knew about where we are going to use the test drivers, where we are going to have test steps. We can combine both of them based on the complexity and the test strategy that we are going to have, and also integration considerations we studied. What are the steps that we are going to consider in terms of hardware, software, environment, emulators, etc. Integration test strategies and comparison we did with a table, like in terms of reusability and availability, etc. Integration test strategies, how we are going to have integration test strategy derived. It could be bottom up, top down mix in terms of hybrid test strategy, in terms of OSS, operating systems, or scheduler centric. We can use a centralized approach. Also we can have a protocol or a network sort of a testing with the help of a layered integration testing approach. We can have a database application, embedded application testing can be done with the help of client server integration test approach. We can have a collaboration mechanism where different subsystems are going to be collaborated while doing the integration testing. Then also we understood about integration test environment, where how the environment in terms of emulation, simulation, the actual target or a host based testing are defined and used. And also we understood about integration from use case perspective, use case diagram example we went through, and also we understood how test cases can be drawn from the use cases and use case scenarios. And also we understood about generating test cases from use cases, the various steps that are involved for developing the test cases for different use cases and their scenarios. And in the end, we have studied about regression testing, test strategy, and importance of automation, and the last one being the uh, maintenance, test maintenance, and regression test build process. So all this we studied in the unit 4. Okay, in the next session we will start the unit 5, which is nothing but test management and defect management. So that will be the last unit of the embedded software testing. After that, we are going to have practical sessions, hands-on questions, and Q&A sessions for the embedded software testing. With that, I'll conclude this unit 4.